On your phone you got a picture, put it in a frame. Pictures getting bigger but the figures stay the same. Scale models on the mind when you print it too small. How you change one side, gotta do to them all. It's multiplication to every dimension. Call it a dilation, not all I'm gonna mention. I got examples, figures similar, all sides multiplied by 8, getting longer, that's a change in the figure they call the scale factor. Gonna trample these problems, trample like a tractor. It's getting bigger, scale factor's more than 1. If it's smaller, then it's less, a reduction. How about the angles, will they change as well? The shape doesn't change, so the angles stay the same. So you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape. So you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape. Sometimes they rotate the figure around, but the scale factor certainly can still be found. But before the scale factor can be figured, gotta figure if the figures are truly and really similar. The corresponding sides, yeah, they got to align like the longest with the longest. No, it's not hard to find. Put the longest of the second over longest of the first. Got the ratio right there, write it down and rehearse. But it's gotta match the other ratios. If not everyone's the same, then they are similar. Answer is no. Hey, do the smallest over smallest and the middle over the middle to simplify the same. Oh, hey, compare the simple matter if they're all the same fraction, then you got your scale factor. So you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape. Yeah, you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape. That's great that they're similar, but how do you solve for the missing sides, the missing angles, all that's involved? The corresponding angles, you know they're congruent. The sides a bit more difficult, you know you can do it, because the sides always change in the exact same way. From figure to figure, the ratio is the same. Setup, equations, they call them proportion. It's a fraction equals fraction, is consistent, no contortions. Take a side from the first over corresponding of the second equals another of the first over second. Just cross multiply, and then you divide. To isolate the variable, got the value of the side, yeah, cross multiply. Then you divide to isolate the variable, got the value of the side.
You're copying me.
So you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape. Yeah, you got that figure, getting smaller, getting bigger, reduction or enlargement, but you gotta keep the shape.
I see you recording.
Got one quick thing before I leave. When solving a proportion, gotta know, gotta see. You can't cross multiply unless you got two fractions separated by an equal sign. No, you can't cross multiply unless you got two fractions separated by an equal sign. You can't cross multiply unless you got two fractions separated by an equal sign. You can't cross multiply unless you got two fractions separated by an equal sign.
Word.